Hello, everyone. Nice to be back at the AEC Hackathon after a couple of years. So my name's Stuart, and I'm the CEO and co-founder of Scaled Robotics. And I'm going to tell you a little bit about the company, what we're doing, why we're doing it, and also kind of go back in time a little bit and look at what we were doing at AEC Hackathon, what feels like a long, long time ago, but it was probably only 2 years ago. So let me just start by sharing my screen. Perfect. So Whisker Robotics, and we are automating progress monitoring and quality control for construction. We believe that construction is incredibly important and is being criminally undervalued or underserved in the technology space. We really haven't seen too many innovations in the last 50 to 100 years in this space. But it really deserves so much more because it's an industry which is literally building the cities that we live in, the homes that we dwell in, and the infrastructure that powers our economies, that allows us to do anything from ride our car from Munich to Berlin to log on to the internet and check out cat videos. The construction industry really is at the heart and soul of everything that we do in our lives. We spend 90% of our lives within the urban environment, and yet, considering how important it is, how much a huge part of our economy it is, we put so little energy into improving and making it more efficient. It is one of the most inefficient manufacturing industries in the world. So to maybe just kickstart our perspective on those inefficiencies, I'm just going to kind of start with a really brief story. So 6 months ago, on a construction site in Oslo, in the middle of winter, as you can see by the ice, a steel beam was brought to the attention of site management, and it was 4 centimeters deviated from where it should have been. And if it had been left undiscovered, it would have cost thousands of euros in extra costs, the valuable time of at least 8 site managers running around like headless chickens trying to work out why their building wasn't basically fitting together, and at least 1 week of schedule delays. And for anyone that's working in the industry now, they know that this is essentially the cost of doing business. These issues are not rare. They pop up all the time. And from that one small issue that's easily solved, you have a whole bunch of downstream second, third, fourth order events and effects which go to damage your project. And the crazy thing is, like I say, it's considered normal in construction. It's the cost of doing business. But the really crazy thing about this particular beam is that this was automatically flagged up to site management within 24 hours so that they could get this issue fixed at no extra cost while the subcontractor was still on site. Now, why did this even happen in the first place? We believe as a company that while we're designing digitally, we're still constructing manually. We put a huge amount of energy into VDC, into BIM, into digital design. You have offices of people that are maintaining these drawings and basically designing all of this stuff in 3D. We're a digital industry in that sense. But in the field, there's someone there with a tape measure and a bit of string, essentially putting things wherever they feel like that day. And if you come to work with a hangover, then you will literally be building a hangover into your building. And I don't believe that people come to work wanting to do a bad job. The contrary, I think most people come to work wanting to do a good job. But if you literally do not have the tools at your disposal to actually build this accurately and rigorously, then, I mean, we're only human, right? We make mistakes. We're not perfect. And it's this disconnection between the digital world and the physical world that causes so much friction and so many problems. And essentially what this does is it introduces a huge amount of risk and uncertainty to our construction projects, to our deliveries. And we're dealing with this risk of basically translating the digital world into the physical world by adding more time to our schedules, more time to delivery, more money in our budgets that we just put in as padding. But what this basically means, this is just a proxy for the fact that we literally don't understand in detail how our project is actually running in reality. And if you cannot measure something, you can't manage it. And if you don't understand a process objectively, how are you ever going to improve it? And if you look at any other manufacturing industry, they have huge amounts of control over every tiny detail of the delivery of that product. But in construction, we have a lot of unknowns. And like I say, a lot of risk and uncertainty within the delivery of our projects. And I mean, what it really comes down to is, whilst we might, like I say, design with 21st century tools and try and deliver 21st century buildings, we're delivering them with 20th century tools. So Scale Robotics is really set up to try and build the next generation of tools for the construction site and to leverage that investment that we've already made into BIM and VDC, and to start bridging the gap between the digital world and the physical world by automating progress monitoring and quality control so that site managers have better information to make better decisions about their construction sites, about what's really going on. So how do we do this? First off, we're capturing data on the construction site, whether it be with this little robot or with traditional terrestrial laser scanners. You can see that this robot is driving around a construction site in Utrecht in the Netherlands. This guy has literally no interest in there being a robot on his site, which, to be honest, is really how it should be. It's just another tool to capture data on your site. And what you may have noticed is this robot isn't just stopping and scanning and stopping and scanning and stopping and scanning and capturing data. It's actually dynamically moving around the environment and capturing information. And it's using a technology called SLAM, which is simultaneous localization and mapping. And this is basically what the robot is seeing. And if you see here, the robot's driving around and its sensors are dynamically capturing that information around it. And it's adding it to that map, not in a static way where it's just aggregating data. It's actually aggregating that data as it goes to build these three-dimensional maps of its environment. So it's driving around, it's moving 10 times faster than you would be able to move with a terrestrial laser scanner, capturing that information as it goes fully autonomously. Now, what you're going to get at the end of the day is going to be a laser scan. It's going to be point cloud data, whether it be from the robot or a terrestrial laser scanner. And this is what you end up with. This is from a site in Norway, and you can see that there's snow and there's ice and there's chaos and there's all kinds of mayhem, people, clutter, materials. And what this basically is like a 30 gigabyte file of completely useless information. This is just raw data. So what we're doing is we upload all of that into the cloud, and we start to run an analysis on that data using computer vision and machine learning algorithms to start trying to get information out of that raw data. So the first thing that we're doing is we're actually cleaning all of that information so that we have good, clean data going into our system. Upload it into the cloud, computer vision and machine learning algorithms get to work. And you see all that clutter and all that noise that we were just looking at before? We take that, and that's basically everything in red. We filter that out, we put that to one side, and then we take the clean data, which is only the actual building itself. You see all the scaffolding and all the materials are filtered out. We take that clean data, so we've got good data going in, good data coming out, and we align that with the BIM, and we run an analysis on every single element within the BIM file so that we can tell you how is your building constructed. We can tell you the state of every single element that you intended to build, which is in your BIM. And the first thing we do is we try and take something incredibly complex and we try and make it as simple as possible. So the first thing that we're doing is we're color coding every single element within the file. So it means that everything that is colored gray means that we don't have enough information to make an assessment. It doesn't mean we haven't seen it. It really just means that there's not enough information or not enough good information to tell you something reliable. So we say no data. Everything green is within tolerance. So it has been built correctly according to the tolerances given us by the client. So that's good. You want your building to be green. And then everything red is missing. So it's not that we haven't seen it. it is that it is genuinely missing and has not been installed on the construction site. So in this case, this is the second floor of a building with 3 floors above it, and a structural wall has genuinely been missed out, which is obviously information that you would like to be brought to your attention, I think, sooner rather than later. And then everything orange, as you've probably already worked out, means that it's out of tolerance. So it has not been built to the tolerances that have been set by the client. Now, what the average construction site ends up looking like with these classifications is this. Everything is orange, everything is out of tolerance, and it is a little stressful as a site manager to be looking at the state of your building. We're kind of like a black light shining across and pulling out all of the deviations and all the dirty little secrets. But honestly, to know that everything on my building is out of tolerance is not useful. This is not telling me what is putting my site at risk today, and what do I need to do? Where do I need to allocate resources to reduce the risk and uncertainty of my project and keep it running smoothly? So for example, on this particular image, I know that one of these elements is significantly more damaging and significantly more deviated than all of them. So from all of those elements, that wall in the middle is 10 centimeters from where it needs to be. And I know that the ducts that are going to go behind it do not now have enough space. And if I had found this at the end of the project when I was handing over to the next subcontractor, this was going to cost me 10,000 euros to solve this problem, minimum. I want that information early. So what we do is we make all of this searchable so that I can come and I can grab that information and I can inform myself. So here we are in a web viewer. This is all powered by Forge. We've got that building. We've got all the color classifications, and I can now go in and I can start searching for this information. I can search by time, so I can go back in time and I can look at information that was previously taken at another date. So I almost have a time machine, or I can look at the most recent information. I can then filter by element type. So I can say, okay, only show me a certain element type, like beams, for example, only steel beams. That's reduced the amount of elements I want to look at to 36. Then I can further reduce that space by saying only show me elements above 15 millimeters of deviation. And now everything within this list is automatically ranked by the magnitude of deviation. So I have all the high rank deviations at the top and all the lower rank deviations at the bottom. I can run my mouse pointer along and I can visualize the deviation using a heat map. So I can visually verify what my system is trying to tell me. And then I can then go in and check out an image where every single element is automatically tagged with every single image where it appears. So I can just look at all the images where that beam actually appears, highlight it in the image so I know exactly what I'm looking at. And I've gone from having almost no information about my site to within 5 clicks, having very fine-grained information precisely about the state of my site. Where are the critical issues, and where am I now going to have to reassign my resources to keep my project running smoothly, communicate that to my subcontractors, and get that issue fixed. So I'm getting good information, high quality information, quickly, while it's still valuable to make better decisions on the site itself. So things like that beam don't slip through the cracks. You have better control over all of that data, all of that information to be able to, like I say, make better decisions. And all of this is only possible through the recent inventions or the recent innovations in computer vision and machine learning that is really opening up the possibilities to be able to automate this process, which really was out of our reach 5-10 years ago. Then we can take the exact same process and not just look at this as a single moment in time, but we can also look at this in terms of progress monitoring. So we can pull out how much progress have you made, on what floor, in which place, and then we can start to extract trends about how that is actually working in 4 dimensions. So we're not just looking at quality, we're also looking at progress over time. And we're able to give you those metrics that you can then use to inform your processes on site to make better decisions about your project. Now, this, I really kind of want to say a big thank you many years ago to Philip Muller, who actually invited us to the first AEC Hackathon. When we were first starting the company, we basically invested all of our resources into the back-end infrastructure to be able to do this computer vision, machine learning, and the robotics side. And basically, we had no way of actually displaying this to our first clients. We'd done all this work, we had all of this data, but we had no idea of how to actually display this to the client. So Philip was kind enough to invite us to the AEC Hackathon. And he introduced us to Jaime, who is working on Autodesk Forge platform. And some of the team attended the workshop and was lucky enough also to be able to present some of our work. And as you can see, that slide of designing digitally but still constructing manually has not changed in like 2 or 3 years. So we're still sticking to the same philosophy. But they were kind enough to invite us, and we went from having literally no interface to be able to communicate to the client to, thanks to Jaime helping us out, we built our first interface here. Let me just play this, which I think is kind of relatively similar to what we have now, but a really basic stripped down version where we could check out those images. We saw the first color classifications of that information. We started to take that raw data and start presenting it to the user. And we managed to go from, like I say, no interface to on Forge within a week. We had a basic interface that we could show to our customer and demonstrate the basic value of what we were doing. And I think it's incredible to look at this, like it really is so rudimentary. But then over the last 2-3 years, we've turned this from first prototype, which was built at the AEC Hackathon, that we've turned into a full product, which we're rolling out around the world. We're now working in the UK, the Netherlands, Scandinavia, the US, Japan, the UAE, Germany. To name just a few on some of the most exciting projects that you could ever imagine. And it really all came on the viewer side from that first couple of days in Berlin, where Jaime really helped us sketch out and produce our first prototypes, which we then delivered to a client within 1 or 2 weeks from that workshop. So I really want to say thank you to everyone that's helped us throughout this journey, especially to Philip and Jaime. And now I think it's probably a good time to see if anyone has any questions about the work that we've been doing.